Hi all, it's me and him again.
Yeah.
Must get sick of us by now. This is another update on our 3D printer. We did promise, didn't we?
We did.
A bit more of an update. Right, I suppose I'll start.
Go ahead.
We've got a close-up camera. We're going to use these bits, but there's a big bit.
Yeah.
Won't show on the little camera. This is just a start of what I'm planning on doing to fix the 3D printer, because for those that don't know, we've got a major problem with the right-hand side.
Yeah.
Dropping and rising and taking the whole thing out of calibration constantly.
Yes.
So what we did is, I'll go to this other camera closer, brought another threaded rod, another coupler, and I brought a pack of little whole pack 5mm rods. We're going to have to cut these down shorter, but the idea is this will have one out of this pack. I've got a whole pack here. There you go, get under camera, there you go, sit there, of these cogs. That's basically, the idea is that will be going on tight to the underside, but that will be up close. Have some sort of bracketing system. We've got a sort of design. This will be up close underneath. A closed band that'll go around and turn both sides to be lifted at the same time. To make it spin a little bit better, I brought a pack, and these are absolutely minute. I was actually quite surprised. Now these are bearings, believe it or not. They're designed for radio controlled helicopters.
Yes.
And radio controlled cars, so they are incredibly resilient, I hope. And basically going to put them on the underside of the rod before the cog to go through, so the whole thing can spin smoothly.
Yeah.
But it's got to be tight, which is why I've got a bearing that's got a 5mm hole. The rod's 5mm, so it's going to jam on.
Yeah.
We can put a bit of arrow up there or something if we need to. Just quickly pass over to Dean, who's going to talk about a couple of the test prints we've done.
Yes.
Also, we found the main bearings which are in the system. These things are very poor. They fall apart easily and they're loose, aren't they?
Yes.
On the rod. So we bought these so-called bearing things, but if you look inside, they're not actually a bearing. They're just all one big plastic piece.
Yeah.
But this is very high. Takes very high temperatures, and where we put this on, like the XY, I think it's on all. Yeah, it is, isn't it? It's on all 3 axes.
Yeah.
It makes them move smoother, and it's actually quieter. When we finally get the 3D printer working with the new double side bits in double thread,
yeah,
then we'll show people how quiet it is. Over to you then, Dean.
Yes. So yeah, just quickly, it's just a short update. Someone on the last short-ish update. So yeah, this is the original. This is a test we've done. It's a companion cube from Portal 2. Yeah, basically it's just the first test we've done. This is using the original filament that comes
PLA.
with. Yeah, the original PLA filament that comes with the printer. Although it wasn't too bad, I mean, you can see a bit of detail on there. You can tell where obviously it's been losing its calibration. You can see peds and lines and streaks.
Losing ain't a word, is it? It really does lose it quick.
Yeah, we did, especially on this side. I mean, I don't know how well you can see that, but there was lines, peds and dips all over the place. We did manage to make it a bit better. We brought some rigid ink.
I know. Just one thing, just quickly. On the bottom of this one, I like that. I can actually see. You can see there's little dots and stuff. That's from the original plate.
Yes.
We didn't put nothing on it, did we?
No.
And the actual ink, the PLA went through the holes, and it was a pain to get rid of. So we tried masking tape
We end up going over to glass.
And went over, gone to pure glass with nothing on it, and it actually worked.
Yes.
Except for the calibration issue.
Yes, I mean, this is our most recent companion cube before it broke again. It does look a lot better. Or you still have the calibration issues, but just this rigid ink is a lot better than the original PLA. The only thing with this one is the bottom is not great. I mean, you can clearly see the lines, and obviously because of the calibration issues, you can tell it isn't a cube, it's a cuboid.
Also, the other thing we did have for that actually was the obviously the bottom doesn't do what it's supposed to do.
Yeah.
The side drifts out. We did try the white PLA, and it's absolutely awful. Doesn't stick to itself in any way, shape, or form, does it?
It doesn't.
We did try. We upped the temperatures. We decreased the speed, increased the speed.
But
put the plate, God knows what, it was actually glowing. And
yeah. But you see, the thing with the white one is it feels bitty when you touch it.
It feels like bits of paper in it.
It feels like bits of papers all over it. It's really low quality. So yeah, the inks, from rigid inks.
Rigid ink, yeah, that's a problem.
With the PLA that comes with it, I would not recommend at all.
No, it's very poor.
It's very poor quality. And even when we did manage to keep in calibration for long enough, it wasn't great quality.
Yeah, never was. I mean, just by looking at these two, I mean, I can't find the best. I'm just going to take this away from the camera just a second. Well, that's the best side of both for the heart.
Yeah.
Now, I don't know if you can get this to go in nice and close or not.
I'm just trying something else at the moment. Cause, yeah, we're trying out some new software, and although it's great and all, there you go.
That's better. Now, I can see straight away that now that's the rigid ink.
Yeah. Oh, something's wrong.
Which you've done something wrong there.
The camera's frozen.
You've frozen the camera.
I froze the camera. The apps.
Right, and what I can say is the rigid ink, the actual. So I'll take everything else. No point being that. The rigid ink. Just looking at these, I can see clearly that's supposed to be a heart embossed inside a dome.
Yeah.
Whereas you sort of can on that one.
But it's poor.
But it's nowhere near clear. I mean, even the tip of the heart point there is absolutely pristine. Now, even though the bottom is gappy,
yeah,
it's a lot smoother.
Yeah.
So it's better using the rigid ink.
Yes.
They're both solid though. I have actually tried breaking it. We haven't got any more test prints because I've broken them all.
Yeah, we were trying to.
We're trying stress testing and seeing how good, how much weight they can take. I mean, one of the rigid ink ones, I was walloping with a hammer, wasn't I, against the wall, and it wasn't breaking. It was really having trouble getting into it. So, but if you remember the white PLA, and the original, I just snapped it with bare hands.
Yeah.
It was just absolutely awful. So, I'd say the rigid ink's definitely one that we should go with.
Yes.
But we need to solve this calibration issue, which hopefully will be done with having a screw on both sides.
Yeah.
So that side doesn't dip. Because what's happening is it's dragging, isn't it? Even with a better bearing.
Yeah.
It's because it's got nothing to force it up and down in the right way. It's sort of dragging behind and then dragging down. So it's sort of up on the way down. It tends to be a bit too high, and the way up it tends to be a bit too low.
Yeah.
And it drags everything out. I think that's it until next time. Until because we've got to wait for some new bits. We've got a metal plate. We've got to cut.
Yeah.
Make the adjustments up for this bearing thing, which I will be putting pictures up of.
Yes.
As and when I can. And I think that's really it until we get some more. Oh no, actually there was one more bit.
Was there?
Yeah.
Oh yeah, there was.
Yeah. Now, for those who knew about our issues, the 3D printer and bits blown up, and how long it took to get bits, we just received this the other day. I sent us another main board.
Yes.
Now, assuming this one works, that's now 2 working main boards we've got.
Yeah.
Along with a handful of step motor drivers.
Yeah.
I've probably got enough to make most of another machine up.
Apart from the actual metal.
The metal work, yeah.
Yeah.
But I mean, I don't like the design of that. I like the overall look,
Yeah.
but I don't like the mechanism of it. I mean, if they'd have done on the right what they've done on the left, 2 smooth bars and a threaded rod and a motor,
Yeah.
that would be a lot better. Although, with 2 motors, which I have read somewhere that they were actually still getting drifts,
Yeah.
which is why we're running ours off of 1 motor.
Yeah.
And 1 motor, 2 cogs and a sealed band.
Yes. Oh no, that's it.
That's it. See you guys later.